Imagine a mountain so tall it pierces the sky and pokes out the top of the atmosphere into open space. A mountain 3 times taller than Mount Everest. A single mountain so wide that its base would blanket an entire country, cover the whole state of Arizona, or drape across most of Italy. It sounds like pure fantasy, but it's real, and it isn't on Earth. It's sitting right now on Mars, our neighbor in the dark. It's called Olympus Mons, and it is the largest volcano in the entire solar system. A thing so colossal, it breaks our sense of what a mountain even is. And here's the strangest part, the detail that turns this whole story upside down. If you were actually standing on it, you might never realize you were on a mountain at all. Today we're going to climb this impossible giant, figure out how it got so monstrously huge, and uncover the secret it might be hiding about Mars's distant past. A secret scientists are still fighting over right now. Stick around, because the truth at the summit is stranger than the size. Let's go. Let's start with the numbers, because they are genuinely hard to believe. Olympus Mons rises about 22 kilometers above the surrounding Martian plains. That's roughly 14 miles, straight up. To put that in human terms, Mount Everest, the tallest mountain on Earth, reaches about 9 kilometers above sea level. Olympus Mons is nearly 3 times taller. If you somehow stacked 2.5 Everests on top of each other, you'd only just be reaching the summit of this Martian monster. It is, without exaggeration, the tallest volcano known to exist anywhere in the universe we've explored. But height is only half the story. And honestly, it's the less astonishing half. Because Olympus Mons isn't a narrow spike, it's unbelievably, almost comically wide. Its base stretches about 600 kilometers across. That's around 370 miles from edge to edge. Picture that for a second. You could set this single volcano down on top of the United States, and it would completely bury the entire state of Arizona. Drop it onto Europe, and it would cover most of Italy. Its footprint spans an area of roughly 300,000 square kilometers, the size of a large country. This is not a mountain in any sense we're used to. This is a geological feature the size of a nation. A bump on Mars so big you could see its shape from space without a telescope. And the sheer amount of material packed into it is staggering. By volume, Olympus Mons is estimated to contain about 100 times more material than Mauna Loa in Hawaii. And Mauna Loa is the biggest volcano on planet Earth, 100 times bigger than our greatest. You could take the entire chain of Hawaiian Islands, every single one, and they would vanish inside the bulk of this one Martian mountain. When scientists call it a monster, they're not being poetic. By every measure we have, it simply dwarfs anything our own planet has ever produced. In fact, this mountain is so heavy that it's literally pressing a dent into the planet. All that piled up rock weighs down on the Martian crust beneath it so hard that the ground around the volcano's base has sagged, forming a shallow moat-like depression ringing the entire giant, a couple of kilometers deep in places. The crust of Mars is, in a sense, buckling under the load, the way a heavy person sinks slightly into a mattress. Think about what that means. This object is massive enough not just to sit on a planet, but to deform it, to push the very bedrock downward under its own staggering weight. There is nothing remotely like that anywhere on Earth. Now here's where it gets wonderfully strange, that detail I promised you. With a mountain this gigantic, you'd expect a towering, sharp, intimidating peak stabbing into the sky, the kind of dramatic spike you see in paintings of Everest. But Olympus Mons is the opposite. It's a shield volcano, which means instead of being tall and pointy, it's broad and gently sloping, shaped a bit like a warrior's shield laid flat on the ground. Its sides rise at an average angle of just 5 degrees. 5 degrees? That's barely a slope at all. Gentler than most wheelchair ramps, gentler than a lot of roads you've driven on, and this leads to a genuinely mind-bending consequence. If you were a future astronaut standing on the surface of Olympus Mons, you would have no idea you were on the largest mountain in the solar system. The slope would be so gradual, so subtle, that it would just feel like standing on a vast, slightly tilted plain stretching to the horizon in every direction. The mountain is so wide and so gently curved that its summit would be hidden far over the horizon, beyond the curve of Mars itself. You couldn't see the peak from the base, and you couldn't see the base from the peak. You could be climbing the tallest volcano in existence, and your eyes would tell you that you were simply walking across flat ground. The scale is so enormous, it defeats the human eye entirely. It's worth sitting with that strangeness for a moment, because it reveals something profound about size. We think of mountains as things that loom, that rear up in front of us, dominating the sky, making us feel small by their steepness. Everest is terrifying precisely because it's steep and sharp and clearly towers over everything around it. But Olympus Mons is so vast that it loses that quality entirely. It's a mountain that hides its own enormity inside its enormity. Its height is spread across such an immense width that locally, it feels like nothing at all. In a way, it's the perfect symbol of Mars itself, a world whose features are built on a scale so far beyond Earth's that our human instincts, tuned to our small blue planet, simply can't grasp them without doing the math. You wouldn't feel awe standing on it. You'd feel it only by pulling back, far back, into orbit, and seeing the whole impossible shield laid out against the rust-colored plains below. Sometimes the biggest things are the hardest to see, precisely because they're so big. So how did Mars build something so absurd, so far beyond anything on Earth? This is where the real science begins, and the answer comes down to a few crucial differences between our two worlds. The first clue is in how this kind of volcano is born. Olympus Mons wasn't built by violent, explosive eruptions blasting rock into the sky. It was built by lava, specifically very runny, fluid lava that oozed out and flowed long distances before hardening, layer upon layer, flow upon flow. Think less of a bomb going off and more of pouring syrup onto a plate, over and over, for an unimaginably long time. Each eruption added another thin sheet of rock, and over millions upon millions of years, those countless layers stacked into a mountain. If you could walk the flanks of Olympus Mons, you'd see the frozen evidence of all this everywhere. The slopes are carved with countless long lava channels, like dry riverbeds that once ran with molten rock. Many have raised ridges along their sides, called levees. The edges of the flow cooled and hardened first, leaving a central trough where glowing lava kept racing downhill. In places, the lava ran through underground tunnels called lava tubes, the roofs of which have since collapsed, leaving long chains of pits stitched across the surface. The whole mountain is essentially a vast, hardened record of fire, sheet after sheet of basalt, the same dark volcanic rock that paves the ocean floors of Earth. It's the runniness of this basaltic lava that's key. Because it flowed so freely and so far before setting, it spread out wide and low instead of piling up steep, which is exactly why the volcano grew so broad rather than so sharp. But Earth has shield volcanoes too. Hawaii is made of them. So why didn't any of ours grow this big? Here is the heart of the mystery. The single most important reason Olympus Mons exists. It comes down to one word: tectonics. Earth's surface is broken into enormous moving plates that drift slowly over the hot interior of our planet. Beneath them, in certain spots, sit what we call hotspots, fixed plumes of rising molten rock that punch up through the crust and feed volcanoes. On Earth, here's the catch. The plate is always moving over that fixed hotspot. So as a volcano grows, the plate carries it away from its magma source, like a conveyor belt sliding a cake away from the icing nozzle. The volcano gets cut off, goes quiet, and a new one starts forming next to it. That's exactly how the Hawaiian Islands formed. A whole chain of volcanoes, each one carried off the hotspot before it could grow truly monstrous. But Mars is different. Mars is a smaller, colder world. And crucially, it does not have moving tectonic plates. Its crust is a single, solid, stationary shell. So when a hotspot started pumping lava up beneath what became Olympus Mons, that spot never moved. The lava poured out, and the crust held perfectly still. And more lava poured out onto the exact same place, and the crust held still again, for hundreds of millions, even billions of years. Instead of a chain of modest volcanoes spread out like on Earth, all that volcanic material piled up in one single fixed location, building higher and higher and wider with nothing to stop it. Olympus Mons is, in a sense, what you get when a volcano is allowed to grow in one spot, uninterrupted, for almost the entire history of a planet. And there's a second ingredient that let it climb so high: gravity. Mars is much smaller than Earth, and its gravity is only about 38% of ours, roughly a third. That weaker pull matters enormously for a growing mountain. On Earth, a mountain can only get so tall before its own colossal weight begins to crush and flatten the rock at its base. Gravity sets a ceiling on how high anything can pile up. But on Mars, with that gentle gravity, the rock could stack far, far higher before its own weight became a problem. The mountain could reach for the sky without collapsing under itself. Weak gravity, a motionless crust, runny lava, and oceans of time. Those four ingredients together created a giant that Earth, for all its fire, could never match. And astonishingly, Olympus Mons isn't even alone. It sits at the edge of a vast volcanic highland called the Tharsis region, home to 3 more enormous volcanoes lined up in a row. And each one of those 3 is, on its own, already taller than any mountain on Earth. Imagine that, a cluster of giants, any single one of which would be the largest mountain on our planet, all gathered in one corner of Mars, with Olympus Mons looming as the biggest of the family. And when so much volcanic mass piled up in one place, it did something almost unbelievable to the whole planet. The sheer weight of all that rock is thought to have been so immense that, long ago, it actually caused the entire outer shell of Mars to shift and tip over, rolling the crust around the planet's core by a huge angle. The volcanoes were so heavy they may have rerouted ancient rivers and rebalanced the spin of an entire world. That is the kind of scale we're dealing with. Geology so massive it can knock a planet off kilter. Now let's go to the very top, because the summit of Olympus Mons holds its own surprises. If you finally reached the peak, you wouldn't find a sharp point. Instead, you'd find a vast, gaping pit, actually a complex of around 6 overlapping craters nested into one another, forming an enormous depression about 80 kilometers across and up to 3 kilometers deep. This is the caldera, and it's not where lava erupted out. It's where the ground collapsed. Each time the great magma chamber beneath the volcano emptied during an eruption, the roof above it caved in, leaving behind these colossal sinkholes. That crater complex at the summit is so wide you could drop an entire large city into it and lose it from view. Standing at the rim, you might not even be able to see the far side. Now here's a detail that sounds almost made up, but it's true. Mars has an atmosphere, but it's extremely thin, less than 1% as thick as Earth's air. And Olympus Mons is so tall that its summit actually pokes up above most of that thin atmosphere. The peak rises into near vacuum. In a very real sense, if you hiked to the top of this volcano, you would be climbing up out of the planet's atmosphere and into the edge of space itself. The air at the bottom is already wisp-thin. At the summit, there's almost nothing left at all. This towering height had a curious historical consequence, too. Mars is famous for planet-wide dust storms that can shroud the entire globe in a haze for weeks. But Olympus Mons and its giant neighbors are so tall that their peaks stick up above those storms. Back in the late 1800s, an Italian astronomer named Giovanni Schiaparelli, squinting through a modest telescope, noticed a mysterious bright spot on the face of Mars. He called it the Snows of Olympus, not knowing what it really was. He was, without realizing it, looking at the top of the largest volcano in the solar system, poking up through the Martian clouds. It wasn't until NASA's Mariner 9 spacecraft arrived at Mars in 1971 and watched these peaks emerge above a raging global dust storm that humanity finally understood the true, staggering scale of what Schiaparelli had glimpsed. It's tempting to imagine future explorers one day standing on that summit, and people have seriously thought about what climbing Olympus Mons would actually be like. Strangely, it might be less of a heroic mountaineering feat and more of an extraordinarily long walk. Remember those gentle 5-degree slopes? You wouldn't need ropes or ice axes to scale sheer cliffs. Instead, you'd face a journey of hundreds of kilometers, trudging gradually upward across an endless tilted desert, the summit forever hidden beyond the horizon, day after day, with the air growing thinner beneath your boots. until you finally climbed out of the atmosphere entirely. But getting to the volcano in the first place is its own nightmare. That same towering height makes landing a spacecraft near the summit treacherous. The air is so thin up there that parachutes barely work, and the loose dust blanketing the slopes would make driving a rover a constant struggle. The very features that make Olympus Mons a wonder also make it one of the most difficult places in the solar system to actually reach. And yet, if humans ever do build a future on Mars, it's hard to imagine this colossus won't become the ultimate destination, the grandest natural monument any human has ever stood upon. But here's a question that might be nagging at you. All of this, the towering height, the collapsed craters, the layered lava, it sounds ancient, finished, dead. Is Olympus Mons just a fossil, a monument to a violent past that ended billions of years ago? And the answer is genuinely unsettling. Not necessarily. Yes, the volcano is incredibly old. It began forming billions of years ago. But when scientists carefully studied the lava flows on its flanks, counting craters to estimate their age, they found something startling. Some of those lava flows are shockingly young in geological terms, perhaps only a couple of million years old. In the grand timeline of a planet, 2 million years is basically yesterday. This means Olympus Mons was very likely erupting in the recent geological past, and it raises a haunting possibility that scientists take seriously. The giant may not be dead at all. It may merely be sleeping. There could still be hot magma stirring deep beneath it, which is why researchers carefully call it dormant rather than extinct. The largest volcano in the solar system might, just might, erupt again someday. And that brings us to the deepest mystery of all, one that scientists are actively arguing about right now. And it has nothing to do with the volcano's size. Around the base of Olympus Mons runs a strange, dramatic feature. A steep cliff, or escarpment, in places as much as several kilometers tall, ringing the mountain like a wall. Beyond it lies a chaotic, rumpled landscape of grooved terrain. For decades, the obvious explanation was landslides. That as the mountain grew impossibly heavy, its own edges periodically collapsed in titanic avalanches, leaving behind these cliffs. And that may well be part of the answer. But recently, some scientists proposed something far more provocative. What if that cliff marks an ancient shoreline? The idea is breathtaking. That long ago, Olympus Mons may have stood as a volcanic island, with its lower flanks lapped by the waves of a vast Martian ocean. When red-hot lava flows hit cold seawater, they chill and solidify abruptly, which can carve exactly the kind of sharp cliff we see ringing the volcano. If this is true, that ring of cliffs is a fossil tide line, a literal high watermark of a sea that vanished billions of years ago, hinting at a warmer, wetter Mars where oceans once washed against the slopes of a fiery giant. Other scientists strongly disagree, arguing the cliffs formed purely from the volcano's own growth and collapse, and that the supposed ocean was never there at all. The debate is unresolved, and that's the thrilling part. The truth is still locked inside those rocks, waiting for a future mission to land, drill, and finally settle it. Because that's what Olympus Mons really is, when you stand back and take it in. It's not just a record-breaking lump of rock, a trophy for the biggest mountain in the solar system. It's a time capsule, a witness that has stood watching over Mars since almost the beginning, recording in its layers the story of a world that may once have had oceans, an atmosphere, and the churning fire of a living, geologically active planet. A world, perhaps, not so unlike the early Earth. Every cliff and crater on it is a clue to what Mars used to be, and what it might still be deep down beneath the silence. And maybe that's the most haunting thing about this impossible mountain. We've measured its height and mapped its slopes, but the giant is still keeping secrets about ancient seas, about whether its heart still burns, about a Mars we've only begun to imagine. Somewhere out there, right now, 22 kilometers tall and wide as a country, Olympus Mons is waiting in the cold red dust for the first human boots to ever touch its slopes. The question is, when we finally stand at the foot of that endless wall and look up, what will it tell us about the world it has been guarding all this time, and about the planet Mars used to be, long before we ever looked up and wondered?